Hello and welcome back. I'm Data Science Dom, and today we go on with our machine learning model to predict Tesla stock prices in the future. So what we will see today, see the volatility. This would be absolutely nonsense. And we see our orange line almost perfectly matches all. Without further ado, let's dive right into it. So last time we stopped at visualizing how the data closing price looks over time. Now we want to start with some easy feature engineering. You don't need to have a big knowledge into how trading works, etc. I will explain it to you. So we have some easy features for the model to make some predictions. First of all, we want to let the model know how the returns were over time. So how we have percentual changes from day to day. Is it a positive day? Was it a negative day? This is done by going to the close price, and in the end we make just a percentage change. This calculates the percentage change to the next row in the end. Then we calculate the moving average. Those are pretty common in grading, etc., where we have like the average values from the previous 5 or 10 or etc. days. We take it for the 5 days, for 10 days and for 20 days. And we can do it easily with Python. Just use df close, then we make a rolling window. We say the window size is 5, and what we want from this is the mean value. We do this 2 more times for the moving average of 10, equal to the df close, and we have a rolling window again. If you can't follow when I'm typing, just either pause the video or I will link you all of my code in the GitHub, believe. So no worries, you will see the code and you will get this to work. So df.close. Again, we make a rolling window. This time it's 20, so it's a bigger size. So it will have more of the values in common. And right now we have like, what is the average value? We also want to see the volatility. Like volatility, I can write the word, of the last 5 values. So how is the standard deviation? How divide those, separate those values from the mean value? It's pretty easy again. We make the close price. We already know the rolling window. The window is again 5. And then instead of the mean, we just take the standard deviation. We also can take the variance, etc. This is pretty cool and pretty easy to do. What we want more is to see how big the change was inside of the candle. Like we take the high to the low. I call it high underscore low. This is the difference of the high value to the low value in the end. Like what bandwidth the whole candle has done. Is it positively? Is it negative? And as we already know, we need to do this also for the open and closed, because the high and the low is just the highest point, the lowest point, but we need to know where we started and where we ended within this time frame. So we take the open minus the df at this close, and at the end we need a target, because all of this are our features. I call it the features, and we need a target, what we want to predict. And you could say, okay, we want to predict the closing price. But if you have in a row with like the 1st of June 2010 the closing price, then we would predict with the values the price of the same day. This would be absolutely nonsense. So we make a target variable, because we want to predict the future, which is pretty cool. We have the df close and we shift it by -1, saying I shift from the next row the value of the close price to the current row, so I can predict the next day. Yes, it's not the coolest part because we only can predict the next day later on, but this can be more adjusted to even predict further values later on. And now we drop missing values, because in the missing value part here, again, we have like the moving average of 20, which means we only have a value in here after 20 data points. Like after 20 days, we have a moving average of 20, because before we can't calculate it because we don't have 20 values. So we need to remove the first 20 rows. And this is, as this is the highest value, we start from the index 19. Index 19, remember, we start index 0. So this is our 20th value in the end. Okay, those are our previous values just at the 20th index. And our new values are what is the percentage return in here, what is the moving average. We see it gets slightly lower. We have a volatility, and we see already here the volatility at the beginning is pretty low because it's 0.4. So it's like around 40 cents. And we see, okay, the stock price movement at the beginning in 2010 over here was not that big. So those values look good. We have a high low, like at this day we had to change from 92 cents, from 39 cents, etc. We have the open close price, which is a bit smaller in the end because we had some peaks at this day, and the target is the close price of the next data point. Okay, so we have our features, we have our target. So now it's time to split the data set. So I make a variable with all the features name we want to use for the prediction. What we want to have, we want the open, we want the high, we also want the low for sure. Oh, okay, like this. We want the close, we want our volume, and sure, we don't want the date in here because we don't need the date for the prediction later on for the visualization or for predicting a specific target date. But right now we only want this. Then for sure our features that we have engineered, because we don't engineer features we don't want to use. So we have the return, the moving average of 5, the moving average of 10, the moving average of 20. My favorite word, the volatility of 5. Then we have the high to low value, and for sure the open to close value, like how suspended between the open and the close. So how we get only those values there, we create an X. And sure, it's uppercase because everybody takes the X uppercase because it's like a matrix in the end. And if you copy code from the internet, usually the X is uppercase. So we keep to this pattern. So we take the data frame and we take the features in here. So we can give a list with names, and we can see the X, for example, and see, okay, it only has these columns now. For the Y, which we want to predict, we only take the df at the target. We also can visualize this, and we see we have atomic values, like only a single value, which we want to predict in the end. Starting from 20, as in 2010, the stock price was pretty low, and going up to 780, as at the end, the stock price increased dramatically. Okay. Get rid of this, execute it, so we have an X and a Y. So now we will need to split the dataset, because we want a training dataset for the training step, where we give in the labels and the training values, the labels and the feature values. And we want to have a dataset for the testing stage, where we only put in feature values, know the target in the end, and compare it for the evaluation. How we do this? We make a split and say, okay, we have right now the length of the whole data set, which was this 2400. And you make it times a number, which is lower than 1, because we only want a percentage of the data points we have in there. And we take right now 80%. So I have 80% of those values later on in the training data frame or the training set, and 20% of the values in the testing dataset. How I separate this, I make an X train, which is equal to x.ilog, so the integer localization. We make a column split. So we start from 0, go until the split, and we split it over time. Then we make the test, which is x.ilog, and we take the remaining parts. In stock price prediction, the most important thing is that we are time related. So I can't split them randomly, because if I give it the 2nd of August and beforehand the 1st of October, then the model maybe get confused. So it's all time related, so we split it now by time and ensure we have chronologically order in there. That's why we sorted it beforehand. We do the same thing for the Y values. ilog, we make the column split. So we go until the split value, and we make Y test, which is y.ilog, and we make the split column, like starting from the split until the end. we need the dates for the testing set to later on either predict a specific date or also visualize those dates. So we make dates test and take df at score date, and you guessed it, we take the ilog again and we start from split to colon, like the split value, the 80% value, which will be around some date in 2017 until the end. And now, to understand how big the data is, we print our training sizes and the testing size as well. Size, then we can make the length of the X train, and we print the test size. I made this uppercase above, so like this, and we make the len of the X test. Execute this, we see, okay, we have 1,900 rows for training and 480 rows for testing. It's usually that it's a lot smaller for the testing stage, because we need to train the model more, that it is good for the data. It's more important that it trains good and we can validate on less data in the end. And now it's time for machine learning. We create a model. We make the linear regression. I guess I was spacing too much in here. And now we make the training stage. That's easy. We take the model, we say it fits, and we give it just the training feature values and the training target values. So we have X train and we have Y train. In this stage, we need both. Just remember it. And then we make the testing. So we predict stage, we predict values. This is also in the operation mode. We just predict the values. Just right now, we know the Y test in here. So we create it, make a new code cell, and we can have a look at the predictions. The predictions are just some values where we see, okay, it's 330 until 650. Looks comparable to the Y test beforehand, as we had a look at it, that we later on have higher values. Like the last one was 750 or something like this. So we are a bit lower, but yeah, there's always an error. We can't have zero error in here. Now it's time to analyze how good our predictions are. That's what we do. We take the MAE, which is the mean absolute error. We compare the test values, which are the correct values, and the predictions of the model. This is done also with the mean squared error. We take the root mean squared error, but therefore we need to take the square root of the usual mean squared error. And I took the wrong one. This is the squared error. And we also use Y test and predictions. And this is a measure. This is mostly common when comparing with literature or other approaches. So you can now maybe not already know how good our model is from the score you retrieve, but if you have later on some other use cases and see how good the model performs based on those values, you will understand how good the model is. So we have here the Y test, we have the predictions, and so we print all of those. So first the MAE, and we round it by 2 because otherwise we have so many decimal points. We take the MAE, we take the 2, then we print the RMSE, also rounded by 2, RMSE 2, and we print our R2 score, the R2 score. And I have a 1 apostrophe too much, have the round, we take the R2, rounded by 2, execute it, and we see we have a mean absolute error of 7.69. And we have the mean squared error, it's just squaring it to make it all positive and then take the root. The R2 score with 0.97 is really close to 1.0, saying our model can really good predict the target variable. As those numbers don't tell us that much by now, we will have a look at the visualization of the predictions. So therefore we make another figure. You already know it, we take this lowercase figure, we make the fixed size again to 12 and 5. Then we plot, first of all, plot our dates, because we want on the x-axis again the dates, and our Y test values. Take the values in here because currently it's a NumPy array, so we need to take the values from there. Then we have the label, which is the actual price. We also plot right now our predictions, so we also need the dates test. We take the predictions, which is the list, so there we don't need to retrieve the values again. We take the label, and the label is the predicted price. Predicted price. And Yes, we could put a title, we could put an X and Y label, but we just put a legend who can separate between the lines. We put on the grid again to see the grid, and we show everything. And now, don't forget to subscribe to the channel and like the video for more. And we see the blue price is the actual price as we had before. And sure, we only have now values from shortly before April 2018 because we only have the test set. So this is a more tighter plot than before. And we see our orange line almost perfectly matches all of those. We have only small deviations. We see, okay, the last price was pretty bad calculated, but it sees that the last price even increases dramatically. So I think for the starting point, it's pretty good. But now you can visualize the data and can say, okay, on October 2019, I could have this price, but this is not good enough. We want to predict the next day price based on a specific date. Therefore, we can retrieve the latest data, which we say it's x.ilog at -1. Just ensure you have 2 times the brackets in the end, because we need to give it as a list in there. Then we make the next prediction. So we predict the value, prediction, or this. The model.predict latest data at the point 0. If we got the next prediction, we can print the latest date, which was this date where we had a look at. It's like this. We move those apostrophes, take the date value, and we got it already. It's the ilog at -1, and we ensure it's a date value. Get rid of this bracket. We print us the latest close, which is the actual closing value, like the correct value. So we go to df at close.ilog -1, and we have a 2 in here. Here we don't have double brackets because we only want this single value, like at the closing price. Here we want the whole X row. And then we print the prediction for the next closing price. Predicted next close. We round, make next underscore prediction, and round it by 2 as well. Execute everything, and we see, okay, our latest data is from the 31st August 2020. The close price, the official close price was 655.7. So it's not the latest point at the end, it's one beforehand. And we see, okay, our prediction would be 648. So if you would have been at the 30th of January and you know this value and see, okay, it's dramatically higher than today, you could invest. So this is no financial advice, even not with those simple model, but you could do this. And this is the first model you successfully created to predict stock prices.